This is Craig Migliaccio with acservicetech, and today we're going over all the different types of recovery hose setups that you're going to use to recover refrigerant from an air conditioning system, and all the different modifications to the hose setup that you could use, such as using manifolds and regular hoses, or using large diameter hoses and Y fittings, valve core removal tools, filter use, recovering A2L refrigerant, as well as standard HFC A1 refrigerants, and a lot more, so stay tuned. And if you want to learn more about working with refrigerants such as R32, R454B, R410A, or even R22, make sure to check out our new second edition Refrigerant Charging and Service Procedures for Air Conditioning book. And so whether you are preparing a heat pump or an air conditioner for refrigerant, we go over all the steps. We go over all the pressures and temperatures for when you're measuring the refrigerant charge and adding refrigerant or recovering refrigerant. And we also go over troubleshooting indicators. So to check this out, head on over to TruTech Tools, Amazon, or over at acservicetech.com. Now let's get into the video. Before we go over the recovery hose setups, I want to go over the importance of removing the valve core from both ports, both here and here. Now we're going to be doing that with a valve core removal tool. And so we don't need this 5/16 end, we just need the 1/4 inch section, and we're going to back out the rod, snug this and snug here, and we're going to screw this valve core removal tool onto the port. So that's a VCRT. We're going to snug it on, but we're not going to do it too tight. And what we're going to do is we are now going to push inwards on this rod until we find the valve core. Then I'm going to push inwards with my thumb here while I'm unscrewing counterclockwise. Now I'm going to do that until we remove the valve core by hearing a little bit of like pop noise, or it's like a slipping occurring on the threading with the VCRT, and that occurred just now twice. And so I'm going to back that up, and then I'm going to turn this valve to the closed position and unscrew this. And so there's our valve core. And so we want to remove this because it's going to act as a restriction at the port during the recovery, and we're not going to be able to correctly monitor the actual pressure that's left in the system. And if you leave the valve core in the port, it's going to take maybe even 4 or 5 times as long to recover the refrigerant. And the other thing is, when you do turn the recovery machine off, the pressure in here may rise. And so what you're really trying to do is you're trying to get down to, say, 0 PSI or maybe -4 inch HG when you're recovering the refrigerant from a system. So then we would just do the same thing on the other side in order to remove that valve core. After we mount both VCRTs to the ports, we want to go ahead and snug these down, because if you snug them down too hard when you're trying to remove the valve core, that will actually kind of block the valve core from even coming out of the ports. So that's just a little tip, to not have this O-ring in the inside squished down too far. It's also referred to as a rubber grommet. And by the way, these valve cores are also referred to as Schrader valves. Here we have recovery hose setup number 1. And this is one of the most popular setups that you can use. We're going to do some variations of this just to show you what you could do with your tools. But basically, this right here is a 3/8 connection. This is a 3/8 hose, and you have a 1/4 inch connector on the other side. You also have another one that's a 3/8 hose, 3/8 connector, and 1/4 inch on the other side. Now these can be 5 foot, such as this right here, and this is 5 foot. But you can see we don't necessarily need that long a one, so a 3-foot one would work for that. Right here we have a Y fitting, and so it goes from 1/4 inch to 3/8. So there's 2 3/8 Ys and 1/4 inch where it comes in at. And so we have a filter dryer that is rated for HFC refrigerants, and the arrow on the filter dryer is this way. And so over here on this side of the filter dryer, we have a female connection. So you have a steel filter dryer with a small 1/4 inch copper bushing in there. And when you tighten that down up to the brass, because it's a dissimilar metal connection, the copper acts as the gasket. And of course you could add maybe a little nylog there or something like that. Here we have a 1/4 inch male fitting to accept our Y fitting. And so this filter dryer is there to protect the recovery machine from any debris. And so you're protecting the pumping mechanism, and you're also protecting the refrigerant that's going into the tank. So this is something that you can build into the price of the job. It's maybe about $7 a piece or something like that, but you know, prices will vary. Over here we have our discharge. So this is the outlet of the recovery machine. And by the way, this is a digital recovery machine. This is the NAVAC NRDD. This has a digital display in order to monitor the pressure. Over here on the outlet, we want a short hose. We do not want a 5-foot hose, because what's going to happen after we recover all the refrigerant from the system, we can also purge the refrigerant from inside the recovery unit. And so the problem is you're still always going to have refrigerant in this hose, in the discharge or the outlet hose. And so you want this as short as possible. And so you could use a 3/8 hose like this. So it's a 1/4 inch fitting on both sides, and it's a 3/8 hose. So you could use something like that, or if you want, you could just use a 1/4 inch hose. So a 1/4 by 1/4 by 1/4. Now over here, this blue handle, you see we're connected to the blue handle port. That's the vapor port of the tank, and that has access right into the top of the recovery bottle. If you have a recovery machine such as this one, the NRDD, it's going to be very efficient because it has a lot of coil on the inside in order to change the saturated refrigerant to fully liquid state during the recovery. And so we could essentially be putting liquid into the recovery bottle. If you wanted to, you could flip this bottle upside down, and so you would have access to where the liquid is in the bottom and just put more liquid in the bottom. However, if you have a recovery machine that does not condense the refrigerant as well by lowering the temperature with a fan or a large heat exchanger, then you are just going to want to have it attached to the vapor port regardless. So we typically are not connecting to the red port because it would have to go through that long dip tube down to the bottom where the liquid is. And if you are recovering and you have high pressure discharge vapor entering, you don't want to be pushing that down through the dip tube and then having that bubble up through the liquid. So we're typically going to have it connected here. Another quick point I want to make is that you're going to have to purge the air out of these hoses and the recovery machine and this hose before you start to recover refrigerant from that system. And so you could do that right over here before you open up the recovery tank. You just have this closed still, and you can purge all the air out right here. If this is on the, say, the recovery option right here, it's going to be able to purge the air right through there. And the other thing that you could do, instead of purging the air and wondering, hey, did I get all the air out of the hoses? What you can do is you can actually just pull a vacuum on this entire hose setup, and you can only do that if the recovery machine is vacuum rated to be able to do that, and this NRDD is. Anytime you're recovering refrigerant, you want to make sure to not overfill the recovery bottle, and so you can only fill this to 80% liquid capacity. So if you want to learn more about that and the calculations and all that, check out our book, the 2nd edition, Refrigerant Charging and Service Procedures for Air Conditioning book. Now I want to point out that this is the most effective and efficient recovery hose setup that you can use on residential and light commercial systems. It's referred to as the 3-hose setup. And so we're using a Y fitting instead of a manifold, and we are pulling the valve cores out at the valve core removal tools at the ports. So we have a hose on every available port there is, which is only 2 over there, and we're using a short, large diameter hose for the outlet hose. And this is the least frustrating method in order to recover refrigerant because we remove the valve cores from the ports. So the pressure that we're monitoring is the actual pressure over inside the system. So when we turn this off, normally the pressure is not going to rise that much, especially if we have the indoor fan running. Of course, we have to have the electricity off to the compressor. The addition of that indoor fan running is going to add heat to the evaporator coil as you're recovering and lowering the pressure of the refrigerant. Hose setup number 2 includes a T instead of a Y fitting, as well as 3/8 hoses with 1/4 inch and 1/4 inch ends. And this T right here is a 1/4 by 1/4 by 1/4. And so this is the female end and these are the 2 male ends. And instead of using a T, what you can use is a valve core removal tool. You just got to remember to remove the valve core or the Schrader valve off of the side of either the T or the valve core removal tool to use the hose setup in this case. And so this kind of setup is what I used before we even had Y fittings. And so you could also use 1/4 inch hoses with 1/4 by 1/4 adapters instead of these 3/8 hoses if you needed to. And if you do use 1/4 inch hoses, make sure to remove the valve core depressor in the end before attaching it to the end of the valve core removal tool so you don't have a restriction there. Recovery hose setup number 3 is just a slight alteration on our first setup, and you can just remove the filter dryer if you don't happen to have one and need to get the job done. The other thing is, if you don't have that style filter dryer and you just have a 1/4 inch by 1/4 inch male fittings on the end of the filter dryer, you can use this small little 6-inch hose right here. And you could use this setup instead of having no filter dryer. Here we have a recovery machine hose setup using the NR7. Now this one has compound gauges and they're like about medium size. And so if we want to see a larger increment, we could add test gauges over here at the ports. And so we can mount our gauge stubs right here at the side ports of the VCRTs. And we could also, instead of that, mount our wireless pressure probes right here. And that'll give us a good, accurate digital pressure measurement in tenths of a PSI to really accurately monitor our pressure in the tubing right here, so we know when to stop the recovery machine. So here's a hose setup with a 3-port manifold and 4 hoses. Now, I don't necessarily recommend this because I don't want to be pulling old refrigerant through a manifold regardless of whether it's digital or compound. The thing is also, this setup is utilizing 1/4-inch hoses. We really want to have a dedicated set of recovery hoses that are thicker in diameter, and so these ones are just 1/4-inch, our normal 1/4-inch hoses. If we do use this setup, you want to make sure to remove the valve core depressor in the end of each one of these hose sections right here, so that it doesn't restrict the flow any more than it already is by having extra hoses and having to go through the manifold. But this setup does allow the monitoring of pressure with the compound gauges that are a little bit bigger than what we already have on the recovery machine. So if you don't have anything else, you could potentially use this setup. I just prefer to monitor the pressure over here at the VCRT ports if I don't have a recovery machine with a digital pressure display. Now, if you're just starting out and you're trying to get like a recovery hose setup figured out, you could use this setup where you have one T right there, or you could use a valve core removal tool as a T right here instead of using a manifold gauge set and that extra 4th hose. Now, for this setup, you'd still want to mount your compound gauge stubs over to the sides of the VCRTs here and here, or you would mount your wireless pressure probes there. Or if your recovery machine has a digital display, you can just monitor the pressure here. So here we have another hose setup, and this is a 4-hose setup with a 4-port, 4-valve compound manifold gauge set. Now, this type of gauge set is specifically made to be able to have this 3/8 port right here attached to either a recovery machine or a vacuum pump. But I would avoid using 4 hoses whenever possible. I would avoid recovering refrigerant out and through a manifold because it's just going to restrict the flow. So you can use this setup and this right here. So basically, if you were to, say, vacuum with this hose right here, you could charge with this one over here. In this case, we have a recovery hose setup, and so we would only be using this 3/8 port to recover. We could use, instead of this 3/8, we could attach a 1/4-inch hose from here to here and just use our service port right here. But I prefer using 3 hose setups and no manifold at all. But if you have a recovery machine that has smaller gauges, you can use the compound gauges that are larger here on the manifold gauge set in order to monitor your pressure while performing your recovery. I just really prefer having a 3-hose setup because that's the setup that you would use every single time for old refrigerant from a system. I wouldn't want to go contaminating our manifold gauge set every time that we're recovering refrigerant through it. I want to show you some hose setups that include some changes right here for the outlet hose. This is not necessarily a hose change, but we did invert the recovery tank. And so this blue handle right here and port has access right to this part of the tank. And so right now with this bottle flipped upside down, it has access to the liquid that's already in the recovery bottle. So if you're confident in your recovery machine as far as it subcooling the refrigerant as it's coming out of here, so if it's changing it to a completely liquid state, you can just go ahead and send it right into the recovery tank, right through what was the vapor, but now is the liquid with the tank inverted. Now you could also add a subcooler between this port right here and this port, or basically tubing in ice water. And so what that's going to do is it's going to lower the temperature of the, say, high pressure vapor if it was exiting as vapor, or high pressure saturated refrigerant, and it's going to try to subcool it before it enters into the tank. So it's trying to change it into a liquid before it enters. And so for that, you would need 2 short hoses and your subcooler or your coil in the ice water. Another thing that you can do on the outlet hose is you could just use a 1/4-inch hose, but you would want to secure that so as it's vibrating, it's not changing the weight on the scale. Now, you could use this hose if you don't have a short, thick diameter hose such as this right here. Remember, you don't want to use a thick, long hose because after you recover all the refrigerant from the system and after you purge the refrigerant out of this recovery machine and you shut this valve, you're going to have high pressure saturated refrigerant, stuck between here and here. And so you don't want to just be losing all that refrigerant when you have a really thick and long hose. And so you could use a 1/4 inch hose if you don't have something like this. Now on the outlet, I don't mind using a valve like this over here. And so I would not use that on the inlet side of the recovery machine because you may be pulling into a vacuum as long as the system does not have a refrigerant leak. But over here you could use a valve. So that's another type of hose you could use as the outlet hose. Another modification you could do on this outlet hose is you could add a T between the port and the outlet hose. And so this T is going to get connected to a valve core removal tool, and you could pull a vacuum right from this port right here for the entire hose setup, including the recovery machine and these hoses that attach to the VCRTs. Now this will be done while the VCRTs at the system ports are in the off position, and this would avoid you having to purge any air over here on this hose. It would also avoid you having to basically guess when you have all the air out of the hoses and only refrigerants left in the hoses if you were trying to purge the air. So you could just vacuum this whole hose setup, and you just want to make sure that your recovery machine is rated to be having a vacuum pulled on it, such as this one right here. And so you could add maybe another T here with a vacuum gauge and a hose over to your vacuum pump. After it's all done, you could just valve this off and then break the vacuum in this hose by opening the VCRTs at the system ports. Now, in reference to recovering A2L refrigerants R32 and R454B, you could use a Worthington A2L rated recovery bottle such as this one right here, which is a 30-pound or a 50-pound Worthington recovery bottle. And so these meet the AHRI guidelines for both M and K in reference to recovering A2L refrigerants. And so they're rated for A2L refrigerants by having this red stripe, left-hand threads, and that specific pressure relief. And so you could use a left-hand thread adapter in order to mount your outlet hose. Now, using an A2L rated tank is not necessarily presently mentioned in the EPA, but it is covered in AHRI guidance documents. And you could use this left-hand to right-hand thread adapter, and you just want to hold this steady as you're tightening this in to make sure that you're not loosening this as you're connecting your hose. The other thing that you could do is you could just use a hose like this that already has a left-hand thread adapter on it already, so this is not needed. And so Navac makes a hose like this in 1/4 inch where it already has the built-in left-hand threads. And so you could just use this hose instead. So this is the push-pull recovery hose setup, and it's typically used on larger systems, so light commercial and commercial systems. So I just wanted to show you what this was so you get a premise of the idea. But essentially, you are recovering the vapor from this recovery tank and you're putting it into the recovery machine, and then you got high pressure vapor coming out of the recovery machine and coming over into the vapor line of the system. Now what that's going to do is that high pressure vapor is supposed to be pushing all of the refrigerant liquid out through the liquid line and right into this red handle port where there's a dip tube that goes down into the bottom of the tank. And so you are trying to push all of the liquid from the system into this recovery tank, and you're monitoring the weight. So when you see the weight is no longer rapidly changing, like you're not adding more refrigerant into this bottle, then you can pause your recovery machine and reset up your hoses so that you can then just use a 3-hose setup, just like the hose arrangements in hose setup 1. And I have that black nitrile glove there just as a color separation so that you can see where the hoses are all going. The other thing that you could do is you could put a liquid line sight right here in the liquid hose. So between the valve core removal tool and the hose, you could have that liquid line sight so that you could see when you have bubbles forming, and it's not just a straight column of liquid going into the bottle and basically you only have vapor left. And that will be the same thing as when you're monitoring the electronic scale to see that the liquid refrigerant has basically all already been put in the tank and the scale is not moving that much because you only have vapor pushing into the tank. You have to remember you're pulling vapor out of this recovery tank while you're pushing new refrigerant from the system into the tank. And so if there's no more liquid left in the system, that recovery scale is going to stop moving. And the big thing about recovering A2L refrigerants is you want an A2L compatible recovery machine. Now, realistically, it's only if there is maybe a leak in the hoses or something like that, and the fan is going to pull air across there and dilute the refrigerant with the air so that it can't ignite. And the reality of it is it's only mildly flammable anyway, and there is no spark. Basically, an A2L compatible recovery machine would be isolating all the switching components and the motors and things like that. So I hope this video on recovery hose setups has helped. And if you're looking for any of the tools used in this video, I've got links down in the description section below. And if you want to learn more about recovery, charging, troubleshooting, preparing a system for refrigerant, airflow, and a whole lot more, make sure to check out our new 2nd edition, Refrigerant Charging and Service Procedures for Air Conditioning book. So it covers all the new A2L refrigerants, manifold and gauge set uses, as well as wireless probes and tees. And so we go over all the step-by-step procedures that you really want to know. So you can check this out over at TruTech Tools, Amazon, or acservicetech.com. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.